and we have a nice relation between them. If we add them, we get 1. This problem was left for the viewers to solve in my last video. Now I'll solve this problem. Well, let us quickly recall the statement of the problem. So a binary operation star on the set of positive reals defined by this formula, a star b equals a by a plus b. Then we have to find the largest and the smallest value of star of 6 ones. So what we have already seen that this star is not associative, and consequently multiple values of this expression are possible due to various choice of parentheses, right? What I'll do, I'll solve it in more general setup, in the sense that this is only 6 many ones, so we'll prove it in general, so any number of ones. So let's do it now. So before that we have some notation. So for k belongs to n, let mk and mk respectively denote the largest and the smallest value of star of k ones. Okay. All right. Now we have a very important observation. What's that? So note that this sequence mk, lowercase mk, is strictly decreasing sequence of positive reals. So let us try to prove this. Of course, mk plus 1. So what is mk plus 1? Smallest value of k plus 1 many, star of k plus 1 many ones, right? And can you see that this element mk star 1, this is one of the values of star of k plus 1 many ones, because this mk comes from exactly k ones. So essentially this expression involves exactly k plus 1 many ones. So this is one of the values of k plus star of k plus 1 many ones, and this being the smallest one, so certainly this is less equals to this. Now we know this star formula, that is mk divided by mk plus 1. Well, now you can see that this mk cannot be negative, because eventually it is star of 2 elements, and star of any 2 element is positive because star is a binary operation, and therefore 1 plus mk is strictly larger than 1. That means this ratio is smaller than mk. So mk plus 1 is strictly smaller than mk, and therefore the sequence mk is strictly decreasing sequence of positive real numbers. So this holds for all k belongs to n. All right. So we'll be using this thing. Okay. Now what? Now think about this mk plus 1. Let us try to estimate this mk plus 1. So what is mk plus 1? So mk plus 1 is basically largest of all possible k plus star of k plus 1 many ones, right? So it is ultimately a positive real number, obviously. And what about the penultimate step? Just before finding that real number, what is the penultimate step? So at the penultimate step, certainly it is of this form, sum a star b, isn't it? Where both a and b are coming from some correct number of star of ones. Alright. Now what is a star b? We have this formula. So this is a by a plus b, and everything is positive, so we can divide both numerator and denominator so as to obtain this 1 plus b by a. Now what? Now this is maximum. That means we want a and b in such a way that this denominator becomes minimum, right? So basically we want to minimize this denominator, which amounts to say we want to minimize this ratio b by a. So we are interested to minimize this quantity b upon a. So b by a is least. Alright. So I'm saying that this ratio is least when b is smallest possible thing and a is the largest possible thing, isn't it? Okay. Now I'm saying that let's look at a. So when a can be the largest possible value, because a comes from star of certain number of ones, I'm saying that a is largest when a is 1. So is least, I'm saying this and I will justify this only if a equals 1. That means a involve only one ones, only one many one, right? That means rest of the k many ones are left for b. So involving k many 1, the least value of b, possible least value of b is, by notation it is mk, this lowercase mk. So only if a equals to 1 and b equals mk. Okay, now let's try to justify this. Suppose this is not the case. What is the meaning of that? That means a is not equal to 1, and a is not equal to 1, that means a involve more than 1 once, right? So that means a is again of the form some u star v, and u star v is u by u plus v, which is again smaller than 1. That means if a is not equal to 1, a must be smaller than 1. Alright. And what is the situation for b then? So b then can involve at most k minus 1 many ones, because at least 2 ones are involved in a and rest of the things are involved in, rest of the ones are involved in b. So b can involve at most k minus 1 many ones. But what is the smallest value on that case? Smallest value of b involving at least k minus at most k minus 1 ones, that is mk minus 1, I mean lowercase mk minus 1. But this being strictly decreasing sequence, mk minus 1 is larger than mk, which means that this becomes smaller than 1, smaller than the previous value, and this becomes larger than the previous value. So this quotient, this ratio becomes larger. It cannot be least anymore. So this is least only if a equals to 1 and b equals to mk. Now if we put these values here, then what you will have? Okay, so just put it here, then you will have thus mk plus 1 equals a by a plus b, so 1 by 1 plus mk. Let's denote it by star. Okay, So now basically we are interested in this uppercase m and lowercase mk, right? So now it suffices to find lowercase mk because this maximum, this largest value is also now involves the smallest one. So it suffices to find the smaller one. So now let's focus on the smaller value, that smallest one. So again, by similar kind of argument, what is mk plus 1? That smaller case, that smallest one, mk plus 1. So again, it is a real number, and at the penultimate step, certainly it is obvious from one element star another element. So let's write it like x star y. So just like before, this is x by x plus y, and this is 1 plus y by x. All right. Now, this is, let's try to estimate this in terms of x and y. So what is this? This is smallest. That means we want x and y in such a way that this denominator becomes largest. That means this ratio y by x is largest. Now, I'm saying that y by x is largest only if, so this ratio is largest when y is largest and x is smallest. Achha. Now both y and x and y involves some certain number of star of ones, right? Now y is largest when y equals to 1. So I'm saying this and we'll justify now. So y equals to 1, and this denominator needs to be the minimum, because you want this ratio to be largest. So this is maximum and this is minimum. So minimum value of x. So since y involves 1 1, so rest of the k ones must be in x, right? So x is basically star of k many ones, and the smallest value for this is mk. So only if y equals 1 and x equals mk. Again, let's try to justify this. If y is not equal to 1, what does that mean? That means y involves more than 1 many ones, which means this becomes smaller than 1, and x now becomes x now involves at most k minus 1 many ones. So even the smallest value of x is at least mk minus 1, and mk minus 1 is strictly larger than mk. That means this becomes bigger and this becomes smaller. That means ratio, this becomes smaller and this becomes larger, so the ratio becomes smaller. So it cannot be largest anymore. So this is the time, this is the situation when this can take the largest value. And therefore, just like before, if we put these values here, then we'll have mk plus 1 equals mk by mk plus 1. And this holds for all k belongs to n. Say if we iterate this relation, then we'll have mk minus 1, just put the value of mk in terms of mk minus 1, so it will become mk minus 1 plus 1 divided by k minus 1 plus 1 plus 1, and then after cancellation it will take this form, mk minus 1 divided by 2 times mk minus 1 plus 1. So we can you can proceed like this, but we can observe that there is some invariant is there, like here the coefficient is 1 of mk and this subscript is k. So sum of this subscript and this coefficient is k plus 1. Here as well the subscript is k minus 1 and that is 2, so sum is k plus 1, right? So here this sum is actually playing the role of invariant. So ultimately we can reach at this m1 divided by k times m1 plus 1, and the value of m1 is uniquely determined, that is 1, so it is 1 by k plus 1. So the value of mk plus 1 is 1 by k plus 1, and k varies over all natural numbers, and also m1 is 1, which is 1 by 1. So we can say that thus this value mk is 1 upon k for all positive integers, and there is a relation from star. We can figure out the value of mk plus 1. So mk plus 1 equals 1 by 1 plus mk, that is 1 plus k. So this is by star, and that value equals, if we multiply both by k, then we'll have k by k plus 1. Okay, we can simplify slightly to get a better form, that is 1 by k plus 1. So mk plus 1 is this, so we can say that mk equals 1 minus 1 by k, but this doesn't hold for k equals to 1, so this holds for k equals 2 for all k greater equals to 2, and we have a nice relation between them. If we add them, we get 1. Okay, and here for this specific problem we have k equals to 6, so the required solution, the largest one is m6, which is 1 minus 1 by 6, that is 5 upon 6, and the smallest value is 1 by 6. All right. Okay, so this is my solution. Thank you for watching this video. See you next time.